Hi, I'm John Persinos, Editor-in-Chief of Aircraft Value News. I'm also a contributing editor at Avionics International Report. If you like this video, hit the like button, leave a comment, share the video with colleagues and friends, and if you haven't already, subscribe to my YouTube channel. Imagine this. You're on final approach into JFK. It's foggy. You can't see the runway. The pilots are relying on one instrument, the radio altimeter, to tell them exactly how far the wheels are from the ground. Now imagine that instrument suddenly gives the wrong reading. That's not a sci-fi scenario. That's the fear that swept through aviation when 5G cellular networks went live near airports. The concern wasn't about your phone. It was about whether new 5G signals could interfere with aircraft navigation systems, potentially putting lives at risk. Today, I'll unpack the 5G airport meltdown, what really happened, what was overhyped, and why, as of October 2025, the story still isn't over. Let's rewind to early 2022. Wireless carriers like AT&T and Verizon were rolling out high-speed 5G networks across the U.S., promising lightning-fast downloads and near-zero lag times. But the FAA had a problem. The specific C-band frequencies that carriers were using, between 3.7 and 3.98 gigahertz, were uncomfortably close to the frequencies used by aircraft radio altimeters, which operate roughly between 4.2 and 4.4 gigahertz. These altimeters aren't just convenience tools. They're crucial for low-visibility landings, terrain avoidance, and even autopilot systems. If they pick up interference, or noise, from 5G transmitters, pilots might see incorrect altitude readings. And in aviation, even a few hundred feet of error can mean the difference between a smooth landing and a tragedy. In January 2022, as telecom companies prepared to flip the 5G switch, the FAA hit the brakes. Major airlines warned of potential flight disruptions, calling the situation catastrophic. Emirates, Japan Airlines, Air India, and ANA all temporarily suspended flights into some U.S. airports. Airlines for America, the industry's trade group, warned that 5G interference could cause as many as 1,100 flight cancellations and 100,000 passenger delays per day. Under pressure, AT&T and Verizon agreed to delay activating 5G transmitters near 50 major U.S. airports, including Chicago O'Hare, Los Angeles International, and Newark Liberty. It was a rare tech truce, but a temporary one. So, could 5G actually crash planes? Probably not directly, but the uncertainty was enough to trigger alarms. The FAA had limited data on how older altimeters would react to strong nearby 5G signals. In 2022 testing, RTCA, a nonprofit that advises the FAA, found that some altimeters could experience harmful interference when exposed to C-band 5G emissions, especially on approach. In other words, not every plane was at risk, but enough of them were to justify caution. To keep operations safe, the FAA created buffer zones around runways and issued airworthiness directives, requiring altimeter upgrades or restrictions on certain landings in low visibility. The ripple effects were huge. By mid-2022, over 80% of the U.S. commercial fleet had to demonstrate 5G resilience or face operational restrictions. Airlines spent hundreds of millions of dollars testing and upgrading altimeters. The FAA, meanwhile, pushed the deadline for mandatory compliance to July 2023, then extended it again to March 2024, and finally to March 2025 for smaller operators and regional jets. The problem? Many regional carriers operate older aircraft, like the Bombardier CRJ or Embraer 145, which use legacy avionics. Replacing or certifying new altimeters isn't cheap. It can run $20,000 to $50,000 per aircraft, not counting downtime. That's a big deal when you're flying short routes with razor-thin margins. Here's where things get interesting. Other countries rolled out 5G with zero drama. In Europe, the same frequency band was used, but regulators required lower transmission power and larger buffer zones around runways. France, for instance, mandates that 5G antennae near airports be tilted downward to limit exposure to flight paths. The U.S., however, auctioned off more powerful C-band licenses, raising over $80 billion in government revenue, and initially allowed stronger tower emissions. In short, it wasn't 5G itself that caused the scare. It was the American version of 5G. So where do things stand now? As of late 2025, most large airlines, United, Delta, American, Southwest, have upgraded their fleets to 5G-tolerant altimeters. The FAA says nearly 95% of U.S. commercial aircraft are now compliant, but not every plane in the sky has made the switch. Some regional jets and cargo operators still rely on older systems, especially in developing markets or smaller U.S. airports. And with new spectrum auctions coming, including potential expansion into the 4.0 gigahertz range, the FAA and FCC continue to spar over safety margins. The good news? We haven't had a single confirmed case of a 5G-related altimeter failure. The bad news? The issue exposed just how fragile aviation oversight can be when technology races ahead of regulation. So, no, 5G didn't crash any planes, but it did crash the illusion that aviation and telecoms live in separate worlds. It showed us that even as aircraft get smarter, the airwaves around them are getting busier. And the next big safety debate might not be about engines or airframes, but about data. Because in the modern sky, your connection quite literally matters. Well, that's it for now. Thanks for watching. And if you have any questions or comments, please don't hesitate to send an email to me at jpersinos@accessintel.com. Thanks so much for watching.